Hello, welcome back. This is Algebra 2, Chapter 8, Section 5, Page 4 of these notes. Now, there were two methods listed near the end of page 3, I guess the middle of page 3, about how to deal with it when you have a fraction and a fraction. This is method 2. This is the one I prefer, but I anticipate you will prefer the other method, which we did in the last example. First of all, we need to find ourselves a common denominator. And if you look at the fractions, our denominators are the x plus 1 and the 3x and this other x plus 1. So our common denominator is going to be just 3x and x plus 1. That will take care of everything. So if we multiply top and bottom by 3x times x plus 1, something kind of magical happens. Now, the numerator is the easier part because you see you had 2x over x plus 1, and now it's multiplied by this. The x plus 1 cancels with the x plus 1 that was kind of causing the problems to begin with. So the 2x multiplies by 3x, and that makes 6x squared. Boom. Happiness, right? Like the best thing ever. Now, the denominator, it's a little bit trickier because you have to do each term separately. So if you're looking at this first term, the 1 over 3x, that multiplies and the 3x cancels with the 3x, so it leaves us with x plus 1. However, I need to erase those blue lines because it's going to be a little bit confusing for what I'm going to do next. I know I just ruined the 3. I'll fix it. The second term, which is the 2 over x plus 1, that also multiplies by that 3x times x plus 1. And in this case, the x plus 1's cancel, and so the 2 times the 3x, and that makes 6x. So x plus 1 happened when the first term was multiplied. 6x happened when the second term was multiplied. It's actually pretty awesome. It makes us have 6x squared over 7x plus 1. And then at this point, you're just pretty much done. I like this method better. I think it's a little bit harder for students to follow it first, though. So if you are just thinking, don't worry about it. I'm going to actually use the prior method on both of the next checkpoints. Speaking of which, boom, checkpoint. Simplify the complex fraction. Now, I am going to do the method 1 first. So, actually, I was just going to do it, but instead, I will wait a few seconds. I'd like you to try to do this, and it does not matter which method you do. If you write relatively small, you can probably fit it in the box. Give it a try. Okay, this is what you should have. At the end, you should have 5x on the top, and you should have 2 times 3x plus 8 on the bottom. If your denominator isn't factored, it's like 6x plus 16. That's fine instead. But you simplify the numerator fractions first. At the same time, you simplify the denominator fractions. And then once you have that, you're dividing fractions, which really means first one stays the same, second one is flipped upside down, and you multiply instead of divide. And then when you do that, you end up with 10x as your numerator, and 4 times 3x plus 8 is your denominator, and then you reduce with some 2's, and then you're done. That's it. So that one actually is certainly not nearly as bad as the prior checkpoints were. So let's look at number 6. Boom. Again, this is one where method 2 might actually be slightly more betterer, but either way, I'm going to do it with method 1, but hopefully you will see it after you've tried it yourself. I'll wait a few seconds. You can pause the video, try it yourself, come back and check. Okay, so here we are. There's a lot going on here. You have to add the fractions in the numerator first, which means you need common denominators. And since the first one has 2x and the second one has x squared, you need to multiply the first one by x over x and multiply the second one by 2 over 2. In denominator land, you actually have the exact same fraction thing. So the first term needs to be multiplied by 2 over 2. The second term needs to be multiplied by x over x. And then you have yourself common denominators in both numerator land and denominator land. And both ways, you end up with 2x squared as your denominator. In the case of the numerator, it becomes 5x plus 14 over 2x squared. In the case of the denominator, it becomes 6 minus x over 2x squared. Once you've got that, once you've got that, you want to flip and multiply. You do that, and then you've got these 2x squareds that cancel, numerator and denominator, because they're common factors, so they divide out nice and easily. You end up with 5x plus 14 over negative x plus 6, or if you prefer, 6 minus x. That's it for page 4 of the notes, and that's it for the section 5 notes. Thank you for watching.